Recording in progress.
In this video, we'll talk about diode and its application. First question, what is a diode? A diode is a component that allows the current to flow in one direction. A diode is a component that allows a current to flow in one direction, and a diode can act as a switch. We can use a diode as a switch. So now let's see a diode and then its explanation. So a diode, here is a symbol of diode. It has positive and negative. Positive anode, negative cathode. Here symbol of diode is a triangle with a line. So diode can be connected in three. A diode can be connected in two ways. It's either the diode is connected in forward bias or the reverse bias. A diode can be connected in forward bias or reverse bias. That's a diode. We can connect in forward bias and reverse bias, a diode. So this is an ideal model. This type of circuit is ideal model. So ideal model, what happens in ideal model? In ideal model, the diode will act as a switch. For forward bias, the diode will be a closed switch. For reverse bias, the diode will be what? An open switch. Is ideal model forward bias, a diode is a closed switch. Ideal model and reverse bias, the diode is open switch. So a diode can only allow a current to flow in one direction. E.g., now if we have a diode here, if you connect a diode or we have a diode, the current will flow in this direction only. It won't flow in reverse. It will only flow in one direction, which is from positive to negative. It will never flow from negative to positive. That's why I say we can use a diode as a switch. The current will only flow from positive to negative. The current will only flow in one direction for a diode. Current will only flow in one direction. Will never flow in reverse bias direction. Is a ideal model. So for ideal model, a diode is being replaced with a switch, and then for forward bias is a closed switch. For reverse bias is open switch. So here is a circuit diagram. So now let's check the calculations of a diode in ideal model. So in ideal model, for diode in forward bias, for a diode in forward bias, FB forward bias, RB is the first bias. For diode in forward bias, this diode we know it has a voltage which is 0.7. In ideal model, we're going to ignore that 0.7 because this diode is being replaced with only a closed switch. So since it's been replaced with only a closed switch, we're gonna ignore that 0.7. Then we just replace it with what? A closed switch. Then from there, we were asked to calculate what? IR and VR. So now let me explain. So since the diode is going to be replaced with a closed switch, what will happen? The V in will be parallel with our R. Since they are parallel, meaning they will share same voltage, then what is the current through R? Is going to be what? V in divided by R is equals to, which is 12 over 1.2. Then the current is 10 milliamperes. Why? Because the diode is being replaced with what? And closed switch. Since now it's been replaced with a closed switch, this will be parallel. There is no voltage there. We ignore that 0.7 in ideal model. So now what is VR? VR, since they're parallel, VR is equals to V in, which is equals to 12 volts. So in reverse bias, the diode is open switch. This ideal model, the diode will be replaced with open switch. If it's been replaced with open switch, meaning where the current we won't flow. The circuit is open circuit. So what happens in open circuit? The current is zero, the voltage is zero. You see? So that's a ideal model. So let's go to practical model. Now here's a schematic for practical model. For a practical model in forward bias, a diode is being replaced with a V source, which the voltage is equal to 0.7. The diode is being replaced with a V source, which is 0.7. Still, in forward bias, it must be positive, then negative to negative. Forward bias. So since now it's forward bias, it's already is what is closed switch. Reverse bias is open switch. Mara now in practical model, the diode is being replaced with a source. It's being replaced with a source, meaning the voltage now is present. The voltage now is present. Okay, so this fourth bias, reverse bias is a practical model. Then let's see how can we answer questions based on practical model. So let's do some examples. So for practical model, so now let me draw a circuit diagram. When we draw a circuit diagram, we don't include a switch. You must know what it's practical model, and then the diode in forward bias is closed switch, in reverse bias is open switch. Then you must know. We won't draw the switch. You must imagine, must have that switch in mind. Or okay, now there's a switch, and then it's forward bias, and then this thing I replaced V source, which is 0.7. So our V in is 12 volts. Then we know VT 0.7. I'm using silicon. So question here, calculate the current. Question says that calculate IR and VR. The question, calculate IR and VR. So now let's see how can we calculate VR. So something, always the voltage, you have V in forward bias, V in must always be greater than what VT for it to allow a current to flow. And let me explain why. If we have a voltage here, it's 12 volts, and then we have a voltage here, and then you want the output voltage. If your voltage is 12 volts here, and your voltage here is 0.7, what is your V out? What is our voltage here? Remember, we have a voltage is 12 volts, and your voltage is 0.7. So what is the voltage at the end? Voltage at the end, what is going to be the voltage at the end? At the end, the voltage is going to be what? 11.3 volts. You see, it's going to be 11.3 volts. But then what will happen if now you have 0.4 and then your starting point, and then now you have 0.7 in the middle? What will be your V out? 0.4 minus this is negative, so meaning the voltage here, you don't have a voltage here. So always you must make sure your V in is greater than VT before you calculate, then so that you can calculate. Then if it's less than, meaning what, it's also open circuit. It's also open circuit. So meaning what, ID and IR, it's going to be 0. Okay, question as to calculate IR and VR. So IR and VR, since these two they're series, they share same current. Okay, since they share same current, meaning what, the voltage across them, they equal to what? To the V in. So meaning what, V in is equals to VD plus VR. The voltage across them is equals to V in. Why they are series? Then the current is the same. So VR is equals to what? IR times R. A voltage across a resistor is equals to the current of the resistor times its resistance. So now we want to derive a formula for the current. So what will going to be IR times R? So let's make R substitute of the formula. Simple, if we make R substitute of the formula, is equals to B V in minus VD all over R. So that's how we derive a formula for IR. Since this is VT, the current is the same, we just take this to the other side. Then if we move it to the other side, it's going to change the sign, becomes negative. Then from there we divide by R. So now let's find the current. Current is equals to 12 minus 0.7 over 1.2. What is the current? 12 minus 0.7 over 1.2 is 9.417 milliamperes. 9.417 milliamperes. The current is 9.417 milliamperes. So always round off to 3 decimal places and write your answer in engineering notation. Always. So R is equals to IR times R. That's the answer here. So the answer is going to be 9.417 milliamperes multiplied by 1.2 K. So what is the answer? So answer is 11.300 V. So VR is equal to 11.300 volts. So now, before we continue, prove your answer whether it's correct or wrong. Since we said the VD plus VR, they are equal to V in. Now we have the values. Let's prove whether our values are correct. So what is V? 0.7 VD plus VR, which is 3.300. So 11.300 11.300 plus 0.7, the answer is equals to 12.00 volts. So now we proved our values, they are correct. So the aim of the video, I was showing you how to derive a formula for a diode when it's in a practical model, and then how to get the current and the voltage. So what is the current for ID, which is the current of the diode? The current of the diode is equals to IR. Why? Because they are connected in series. They are connected in series. When they're connected in series, the current is the same, but the voltage is different, because the sum of their voltages is equal to VA. So that's how we derive a formula for a diode for this kind of circuit. That's how we derive a formula for this kind of circuit. So now, what will happen if now this thing was connected in reverse bias? Let's see what will happen if our connection was in reverse bias. If it was in reverse bias and is practical model, we know still we will replace the diode with what? With a V source, which is 0.7. But since it's reverse bias, what will happen? The switch is open switch. It's open switch. It's open switch. So now this is reverse bias because of this. It's reverse bias. Why? The terminal are swapped. When is reverse bias? How to determine whether it's reverse bias or forward bias? Reverse bias is when negative to positive, positive to negative. You see. So in reverse bias, what will happen? We know it's practical model. If it's practical model, it's open switch. So if it's open switch, it's open circuit. If it's open circuit, the current won't flow. The current won't flow to the resistor. The resistor won't receive a voltage. So what will happen? Simply, IR is going to be equal to 0 amperes, meaning VR is going to be 0 volt. So when it's in reverse bias and practical model, so the current and the voltage of a resistor 0, because it's open circuit. Because it's open circuit. This is because it's open circuit. So that's a basic circuit. Basic circuit on a diode and its application. So now let's do a two examples, interesting circuits of a diode. Let's do two example interesting circuits of diode. Let's do them. Or if I don't have electricity. So if you like this video or you learn something, please subscribe and share with your friends. See you in the next video. We'll treat questions based on diodes circuits in practical model. Thank you.